My name's Eric. I'm from CrowdStrike, and I'm here to talk about a Chinese eCrime actor called Radiant Spider. Let's get to it. Oh, and there's the title slide again. So here's our agenda for today. We'll spend a little bit of time talking about the deep dive on the adversary's TTPs, discuss the adversary's formjacking using the silent skimmer family, go into some detail as to our reasoning as to why we assess this is likely a Chinese origin eCrime actor, both sides of that, and then conclude with some recommendations for protecting your enterprise. So before we begin, a little bit about myself. I've been working in threat intelligence for over 10 years. I do emerging threats research at CrowdStrike, previously worked at Deloitte and the Department of State. I presented at the Stand CTI Summit, Virus Bulletin, and most importantly, previous editions of SLEUTHCON. And I've included some contact information there as well. Also, a special thanks. This presentation would not have been possible without research from several other great teams on CrowdStrike. So big thanks to my colleagues on Falcon Complete, Falcon Overwatch, and Incident Response Services for contributing to the Radiant Spider adversary. So this is Radiant Spider at a very high level. We're going to go through each of these bullets in turn. They're an opportunistic adversary. They compromise Windows IIS servers via view state deserialization or exploitation of some deserialization vulnerabilities in .NET components. They seek to execute a lightweight PowerShell backdoor for persistent access. They intermittently use web shells and CobaltStrike as well. They monetize access with the Formjacker family silent skimmer. And as mentioned, they're likely Chinese in origin. So let's spend some time going into a deep dive of the adversary's TTPs. For initial access, one of the ways they achieve initial access is what's called view state deserialization. Some of you may be asking, what is view state and why do I care about it? So IIS uses view state to maintain page state in web applications, right? Because HTML is not stateful, it doesn't have state, but we want to persist information in a user's session, right? Things like user enters information into form being a pretty typical use case. So the way IIS does this is through what it calls view state. This is just a dictionary of information. It's serialized into a base 64 encoded string, and it sits in this hidden field called underscore view state, and then the client will post that back to the server. So what's the big deal? Why do I care? Well, turns out some enterprising researchers have found that you can actually run code on IIS servers if you're able to forge a valid view state in your post request, because the content just gets deserialized, and then there are these cool .NET gadgets that can do basically whatever you want, execute commands or run whole in-memory .NET frameworks. And very conveniently, you can go to GitHub, download a tool called YSOSerial that will trivially solve the serialization process for you. So, if you just want to run commands or whatever. Now, fortunately, Microsoft uses what they call message authentication code in modern forms of view state to prevent trivial tampering. So most days you can't just literally use YSOSerial to form a payload and expect that to work, because these days the view state content is effectively signed with what's called a validation key, and this resides in a value called the machine key on the server. So the server will check to see whether the content has been signed by the appropriate validation key, and if it has, then it'll say, okay, then I'll go deserialize the contents and do whatever you need to do. So adversaries understand this. So most view state deserialization campaigns these days rely on either stolen or reused validation keys. So stolen key would be the adversary previously gained access to a system, captured the validation key, or maybe they got the validation key from a different IIS server within a victim environment. They take that, serialize a payload, sign it, send it to the server. Reuse validation key values. This is an issue that keeps popping up because it turns out that we've seen IIS systems at different enterprises actually had the same validation key due to some sort of quirks in the way that IIS works. And of course, researchers have helpfully documented this on GitHub. Adversaries know this. They can go to these lists of these sort of known shared keys and try to use them to sign their payloads. So, as mentioned, you sign the view state content with the right validation key. That passes the MAC check, and then the server will deserialize the content and .NET will do cool things to effectively execute your code. So that's cool. We've seen adversaries do this in a couple different ways. Radiant Spider primarily uses this to deploy web shells. The other way that the adversary achieves initial access is through exploitation of, once again, deserialization. In this case, these are software vulnerabilities in some products built on .NET. I mean, I would highlight that each of these campaigns exploited vulnerabilities that were multiple years old, not just same year. This was end day in the very broad sense of the term. So patches had been available for years, but they still were able to achieve access because people didn't bother to patch their servers. The first campaign we saw was October 2022. This is a vulnerability in .NET Nuke CMS. Second campaign in May of 2023. This is a popular vulnerability in Progress Telerik UI. The fourth campaign was recently in February of this year. These are two related vulnerabilities in the Sitecore CMS framework. All right, so once the adversary is able to pop a command shell, they typically like to run a backdoor based on a project called Reverse PowerShell, which we'll talk about. But I want to step through the 4 different execution paths that they may follow. So the first is MSHTA. So they will use the MSHTA utility. They'll run it with a single argument. The argument specifies a URL. You see here, remote HTA file. Those HTA files are typically pretty rudimentary. Just spawns PowerShell with the flags you see there. That's no profile, hidden window, encoded command. The encoded contents are the reverse PowerShell backdoor. The second way they do this is by downloading a remote PowerShell file and then executing it. So they will use the invoke web request commandlet, that's IWR, download file into C users public, and then they will execute it with the execution policy bypass flag. Third execution path is executing a remote PowerShell file. So they will instantiate a new net.web client object, use that to connect to a URL specifying the location of the remote backdoor, and that's the backdoor. And then fourth, and perhaps most bizarrely, is literally running an unobfuscated, stripped-down version of the backdoor on the command line. No encoding, no obfuscation, just here's my backdoor, because I guess that also works. So what's the reverse PowerShell backdoor? This is actually an open source project on GitHub. It's pretty rudimentary as you see here. It's like 64, 65 lines of code. It does basically what do you think it does? It's just a basic reverse shell. But what's interesting is the adversaries actually implemented some changes to extend the functionality of this backdoor. So they added some capabilities we'll talk through, but they also added some Chinese language comments, which I thought was interesting because those don't exist in the base version. And all the comments that we saw were just explaining what the code's doing, but still interesting to note. The other thing they added, you see there in the orange, there's some essentially print statements there that, again, those did not exist in the original backdoor. And what's interesting is some of those statements use non-idiomatic versions of English, right? A native English speaker would probably not say upload continue. So I thought that was interesting. This slide lists some of the added functionality that the user has incorporated in their updated modified versions. There's privilege checking with who am I, time stamping, that is modifying the file last access creation and last write stamps to mess with defer. SQL Server interaction, uploading files from the compromised host to a C2, downloading files over the remote connection, downloading files using certutil, searching the file system, and they added the ability to clear event logs upon exit, so that did not exist in the base version. In terms of additional persistence mechanisms, I mentioned the adversary likes to use web shells, so you would see these dropped via the compromised W3 WP process. In some cases, the downloaded web shell is actually downloaded in encoded form, so they will decode the web shell using the certutil utility. Most of the web shells we've seen have been variants of the popular and much beloved Godzilla web shell, but we've also seen some lower prevalence, maybe custom web proxies as well. The adversary sometimes uses the popular CrowdStrike beacon tool. We've seen them deploy them via either exe loaders or PowerShell loaders. They've used the popular FRP, open source reverse proxy. And in terms of creating new users, they do tend to like the user named ASP.NET $. In terms of privilege escalation, credential access, and discovery, we've seen the adversary use the God potato and bad potato exploit binaries and the lasagna credential harvesting tool. Connectivity testing, almost everyone uses NSLOOKUP and ping, but not everyone uses NSLOOKUP and ping for the domains here. So they use subdomains of 1433.eu.org, dnslog.cn, dnslog.myfw.us. We also see NSLOOKUP commands for burpcollaborator.net subdomains. This, of course, indicates use of the popular pen testing tool, Burp Suite. The adversary does info gathering using the pretty standard utilities you see in the first bullet. The second bullet lists a perhaps more interesting command. I wasn't familiar with this utility till I looked into to Radiant Spider. So fsutil can do some various file system things, but they always run it with this fsinfo drives parameter, and that just lists drives on a machine. I don't know why they like that command, but it is distinctive. And then they sometimes download the open source network scanners fscan or netspy. Finally, of course, they like to monetize their breaches. They do this with formjacking, i.e. capturing user credit card data entered into a website. So the way we saw them do this was they modified a victim e-commerce page to load a remote obfuscated payment.js hosted on a different domain. This JS decoded to silent skimmer, which some other security companies have reported about, so I'll just briefly discuss it. The way it works is it checks every 200 milliseconds to see if a particular payment button exists. If it finds it, if the payment button is found, Silent Skimmer adds an event listener. It checks to see if a user clicks a payment button. And then when the user clicks the button, the script captures the contents of the fields you see here. So that's the credit card number, expiration, CVC, and the customer's name, concatenates that into a string in addition to a UID for the victim site, encodes it into a base 64, and sends it to the adversary C2. All right, I want to spend some time now talking about the attribution process and why we assess this was likely a Chinese eCrime actor, both sides of that. So this slide lists several Chinese characteristics of Radiant Spider, and while I'm going to step through all these, I want to emphasize that each of these alone in isolation without the other factors would not be sufficient to support an assessment of a Chinese origin of this adversary, right? Each of these are relatively low confidence. However, when we combine all of these factors pointing to China, in addition to the fact that we simply have nothing to contradict, all of these factors, nothing pointing away from China, in other words, we can be confident in our assessment this is likely a Chinese origin actor. So let's talk through these. First, Chinese characters were present in the modified version of Reverse PowerShell. And although Reverse PowerShell, that's an open source tool, the modified version of Reverse PowerShell that Radiant Spider has used is quite low prevalence and likely exclusive to that adversary. Additionally, Radiant Spider has used a variety of open source tools that are both authored by and principally popular among Chinese actors. These include, of course, Godzilla, the FRP proxy, and the NetSpy and FScan tools. All of these we've seen a variety of Chinese origin targeted intrusion actors use across many years. The adversary likes to test connectivity to 1433.eu.org or dnslog.cn. Again, these are domains that we've seen Chinese origin targeted intrusion actors test connectivity to. The adversary uses an extraordinarily high prevalence CrowdStrike campaign ID listed there, which, that's not exclusive to anyone, so not exclusive to China, but, it's interesting. We have seen several other Chinese origin target intrusion actors, use CrowdStrike with that campaign ID. And conveniently, a plurality of Radiant Spider's campaigns occurred between 4 and 8 UTC. This lines up very nicely with pretty reasonable working hours China time. That's between 1200 and 1600 China time. And so we have a lot of factors that indicate this is likely a Chinese origin actor, but I want to emphasize the TTPs we just talked through diverge significantly from known Panda adversaries. This is not the way a Chinese target intrusion actor operates at all. And let's talk through these on the next slide. So we assess this is likely not just a Chinese actor, but specifically a Chinese criminal actor. And we base this on the following factors. First, the adversary's opportunistic victimology. Obviously, we see them at e-commerce victims, but we've actually seen them kind of across a smattering of other sectors across multiple countries in North America and East Asia. And we assess this likely means the adversary is adopting essentially a spray and pray approach to achieving initial access. They aren't really that picky about where they can get it in. They're probably just, using the methods we talked about before to try to get in anywhere they can, and then are likely only going to operationalize the breaches where they feel that they can actually, deploy silent skimmer. And this diverges from the average Panda, which tends to be a little bit more picky and a lot more deliberate in terms of their operations. They're not usually being quite as broad or as noisy as this adversary. Second, as mentioned, the adversary deploys a Formjacking family to capture payment card details. We've never seen any Chinese target intrusion actor ever do Formjacking. That's just simply not in their MO. Conversely, we expect Chinese target intrusion actors most of the time, to engage in targeted collection and exfiltration of sensitive data. But we've never seen Radiant Spider do that at all. They only seem to be interested in Formjacking. And then finally, obviously, the Chinese target intrusion space, this is a broad, diverse ecosystem with a variety of preferred hosting providers. But we do see that Radiant Spider's chosen infrastructure does diverge from hosting providers and ASNs in particular that are more characteristic of Chinese Nexus target intrusion actors. All right, I'd like to spend some time now concluding with some recommendations for protecting your enterprise from Radiant Spider. So view state and deserialization vulnerabilities. First, maybe this is obvious, but patch and update your web applications. I mean, Radiant Spider is able to achieve initial access in the 3 campaigns we mentioned using vulnerabilities that were multiple years old, for which patches had been available for many years, but they still got enough success because people didn't bother to patch their servers. So patch your servers. Second, consider analyzing IIS log files, sending them to your SIM or other analysis tools, particularly those relating to .NET, to detect general abuse of .NET through deserialization vulnerabilities or view state specifically. In terms of view state, definitely consider auditing your IIS servers and indeed the build images that you use for your IIS servers to see whether any of them implement hard-coded machine key values to reduce your attack surface to view state deserialization. And where feasible, consider auto-generation of these keys, right? Because if someone steals a machine key from one of your servers, they could potentially use that to gain access to other servers that implement the same validation key that we mentioned. They can just sign the view state payload and get access potentially elsewhere in your environment. Now, I would emphasize this is not always feasible. If you have, say, multiple servers behind a load balancer, each of those servers would need to attend to a particular user's session with that web app, right? So they would all have to have access to the same validation key to be able to process what's in the view state that a user is posting back. But where feasible, consider swapping that out for auto-generation. And then, if and when your IIS servers get compromised, definitely look into changing hard-coded machine key values, because adversaries understand machine keys and view state deserialization. And so some of them seek to actually capture the machine key that contains that view state. And so the risk here is, okay, they get in, you kick them out, you patch the server, you wipe the disks, whatever, you reset user credentials. But if you didn't change the validation key, then they can just go to WISO serial, serialize their payload, whatever it is, sign it with a validation key, and then they're back in your system, really, really quite trivially. So definitely consider changing out hard-coded machine key values, considering those compromises. But I would note anytime you're messing around with this, obviously backup and test first. the machine key may be important for app compatibility. So make sure that you're not breaking anything when you do that. There are a variety of detection opportunities for Radiant Spider's behavior. Let's talk through these. So first, you may not expect MSHTA to be executed with a single argument specifying a remote URL, HTTP followed by IP address followed by file name.hta. Several different PowerShell opportunities here. So PowerShell executed with the invoke web request commandlet in combination with the out file parameter to write a file to C users public. PowerShell generally executed with execution policy bypass. MSHTA spawning a PowerShell child process with the flags mentioned here. Again, that's no profile, hidden window, encoded command. PowerShell instantiating a new net.web client object to access an external resource. In terms of web shells, as mentioned, sometimes the adversary will download the web shells in encoded form. So you may not necessarily always expect certutil executed with the decode flag pointing to ASP and ASPX files in particular locations. And of course, generally, you may not expect your web server processes to be writing ASP and ASPX files all the time, or certainly not to particular locations. NSLOOKUP and ping, these are, of course, legitimate utilities. People in your enterprise are using them all the time, but you may not necessarily expect NSLOOKUP and ping commands on your IIS servers pointing to subdomains of 1433.eu.org, dnslog.cn, or dnslog.myfw.us. Similarly, fsutil is obviously a benign utility. fsutil executed with fsinfo drives is not inherently malicious, but this may be pretty low prevalence in your enterprise, and in combination with the behaviors here may be useful as a detection. New user creation, again, we mentioned that ASP.NET $, you probably aren't seeing net used to create users with that name all the time. And then, of course, for protecting against formjacking generally, consider implementing file integrity monitoring. This would alert you to really any unauthorized changes to your web pages. And I'd like to close now with some lessons learned and thoughts on intelligence research, tradecraft in general. Because, it took us a little while to connect the dots on Radiant Spider, in part because we didn't have the whole attack chain, but in part because it wasn't immediately obvious that Radiant Spider was, in fact, a spider, right? We mentioned those Chinese characteristics earlier, right? At first glance, if you only have a couple points of data, you say, oh, well, looks like China, it's got to be target intrusion, right? Because all Chinese actors are target intrusion, right? It's all the same. So it took us a little while to really connect the dots. And so these are the lessons learned. First, document everything. You may not and probably shouldn't expect to be able to attribute some brand new case to some brand new adversary, right? It will take multiple cases, potentially across multiple years, to be able to crypt up a new adversary, as was the case with Radiant Spider. Second, make your information easily accessible. If I can't find my notes or someone else's notes, case data, it's almost irrelevant. Like, it almost doesn't matter whether we had any data on it because I can't find it. So make it accessible, whether this is as simple as Elasticsearch or other databases, whether this is Google Drive, Box, Atlassian, or, everyone's favorite task management tool, Jira. Make it accessible. Third, hunt characteristic command line patterns. So all the behaviors that we mentioned on the previous slide, none of them are super high fidelity, extraordinarily unique. No one of those command lines you would look at and say, that is 100% Radiant Spider, #attributed, right? No. But the combination of all of those behaviors together on the same system in the same, process tree, within a short period of time, that is highly indicative of Radiant Spider. Even those, even the perfectly benign, NSLOOKUP or fsutil commands. YAR rules, write them for everything. I would not say that Radiant Spider is what you typically consider an extremely advanced or sophisticated adversary. But their tooling was certainly low prevalence enough and interesting enough that it was absolutely worth writing YAR rules for. So nothing is beneath you. You know, if you can write sufficiently performant YAR rules and they're not extremely noisy, they're not matching on all sorts of garbage, you should put them in your pipeline and have them there, because you never know, 2-3 years later, they might start matching on things that help you finally connect the dots to a case that hopefully you documented and stored in a way that was accessible, right? And then finally, we talked about the Chinese links, but many low confidence links can add up to a high confidence assessment, right? No one of those Chinese characteristics we mentioned earlier would be remotely sufficient to justify an assessment that this was a Chinese origin actor, right? We needed all of them together, in addition to having an absence of any contradicting information to justify our assessment. All right, so this concludes my presentation. I'm happy to take any questions you may have at this time, or since we're right before the coffee break, immediately afterwards.